Welcome to section 5. In this section, you're going to learn about objects in JavaScript, and this is good because objects are essential for JavaScript development. An object allows us to store related pieces of information in a single central location, and that's good because all the apps we build are going to have related pieces of information. Think about a note-taking application. What really makes up a note? It is a title and a body, and those are both strings. So we have these two strings and we want to store them together to represent a note as a whole. With objects, we can model other things like users. A user is the combination of an email, a password, a name, and anything else we might be able to come up with like our age or a profile picture. We could also use objects to model things from the real world like a book. A book has a page count, a title, an author, the publisher. We store all of these pieces of information together and we get everything we need to represent the book as a whole. Now, I don't expect this concept to be clear just yet, and that's why we have this section. So let's go ahead and dive right into objects and see how this is going to help us build real-world applications. In this video, you're going to learn the syntax for creating and working with objects in JavaScript. So let's go ahead and kick things off by creating a new folder to store all of the code from this section. I'm going to call this folder objects. And inside of the objects directory, we're going to create a single file for this video, objects-101.js. Now, as I mentioned in the section intro, we can use objects to store related pieces of information in a single place. This allows us to model things from the real world like books, cars, or people. For a car, we have a make, a model, a color, a year, a VIN number, as well as other pieces of information. For a book, we have a title, author, and page count. And we can also model things from the virtual world. A video game has things like the title, the publisher, the price, all sorts of information along those lines. The important thing to note is that it's all related to a single entity. We can use an object to describe a car or a person by storing all of the pieces of information that make that thing up. So let's kick things off by making our first object, and we're going to model it after a book. Now, there are a ton of different properties that we could talk about related to books. We're going to focus on 3, the title, the author, and the page count. So right here, let's make a new variable. Let my book equal, and now we're going to define the object. Now, what comes before the equal sign has always been the same. For strings, booleans, functions, we use let variable name equals. It's what's after that's different. And for objects, what we do is we open and close a set of curly braces. Now, you'll notice there's no keyword associated with these curly braces like we saw with if statements, the if keyword, or functions, the function keyword. To create an object, we just open and close a set of curly braces. Now we can hit enter to format things a little bit like this. And what we're going to do is define the various properties for this object. So when we have an object, we have properties. These are pieces of data. We have the title property, the author property. We have the page count property. A property just describes a piece of data stored on an object. So let's add our first piece of data, the title for the book. To add a new property onto an object, we start by giving it a name. Much like we name variables like my book, we also name our object properties. I'm going to call this one title since I'm storing the book's title. Now, after the name for the property, we use a colon and we add the value. Now, I'm going to add a space here for formatting purposes, and the value for the title is going to be a string. In this case, the first book I'm going to model is 1984 by George Orwell. So now we have an object with a single property title, and that property's value is the string 1984. You can add as many properties as you like to an object. To add another one, we just put a comma after the first one. And on the next line, we follow the same format. The property name, author, colon space, the property value. 1984 was written by George Orwell. Now we can add a final property onto this object, a comma after that one. And right here, we add page count. And the page count for 1984 is something like 326 pages. And this is the last property that we're going to add for the moment. There is no need for a comma after the last property, just for the other ones. Now we have this object in place, and what I want to do is just use console.log to dump my book to the terminal and see what we get. So console.log, passing in my book, which is the object. Let's save the file and run things from the terminal. Over in the terminal, that would be node, whoops, I'm in the wrong directory, cd ... to get out of functions, / objects to get into objects, and now I can run the node command. Node objects -101.js, and when I execute it, what do I get? Well, I get what looks like the object we created. I have some curly braces, and I have all of my properties. I have title, 1984, author, George Orwell, and page count, 326. So here we're dumping the entire object to the screen, but that's not particularly useful. What's a little more useful is figuring out how to get a single value off of an object. For example, if I want to print a message about this book, let's say I'm selling it on my website, how do I pull out the individual pieces of information? How do I get one of the object properties? This is done via dot notation, and it's called dot notation because it uses the dot key on your keyboard. So my book, followed by a dot, followed by the property whose value we're trying to get. In this case, let's say we're trying to get the title of the book. So I would put dot title right there. And you can see that Visual Studio Code is actually providing a little auto-completion. It's showing me the various properties available: author, page count, and title. I could either type the property or I could just pick it from the list, and VSC auto-completes it for me. Now that we have mybook.title, let's go ahead and save this file and see what happens when we rerun the script. I'm going to run things from the terminal, and now I'm getting the string 1984. So instead of just getting all of the object properties dumped to the screen, I'm actually just pulling off a single one, the string, and using it in a way that's meaningful for me. Now we could take this a step further and use all three pieces of information inside of a template string. So for example, I could create a template string, and I could start off with the book's title. So I would add my $ and curly braces. In here, I would use dot notation, my book dot title. After the title, I could say by followed by the author. So in this case, $ curly braces, the author, my book dot author, to pull that property off. Now I could use the page title if I wanted to, but in this case, let's just go ahead and use those two. If we rerun the program, we're now going to see that formatted string, 1984 by George Orwell. We created it using template strings. We pulled the value off of the object using dot notation. So we know how to define an object, and we know how to read properties off of an object, but we can also change an object's properties. Let's go ahead and explore how we can do that down below. What we're going to do right here is try to change the title of the book to a different George Orwell book, like Animal Farm. To do this, we also use dot notation, but in a slightly different way. So we used mybook.title to read the value of the title property, but we can actually put an equals sign after this to set the value of the title property. So now we're setting a new value for mybook.title, and I'm going to set that equal to a new string. This string is going to be Animal Farm, another book by George Orwell. Now we could actually take this console.log line, copy it, and duplicate it down below so we can see the results before and after our change. Let's rerun the script and see what we get. Over in the terminal, I rerun things. I get 1984 by George Orwell. We then have our change to the title property, and I do get that changed property value showing up. We have Animal Farm by George Orwell printing. So those are the three essential things we're going to be doing with objects. We're going to be creating them, we're going to be reading property values, and we're going to be changing property values. When we put all of this together, we have a really nice way to create models of real-world things. In this case, a model of a book. Now I want you to create an object on your own. Down below, I'll add a little challenge area to the file. What you're going to do is model a person. Now there are plenty of different properties we could include in this list. We're going to include just three. Their name, you can just use their first name. Their age, stored as a number, and their location. You can just use the city or country or whatever you want for that. Now the goal is to create this object and then generate a string based off of the object property values. And the string is going to look a little bit like this. For me, it would be Andrew is 27 and lives in Philadelphia, period. And I'm going to go ahead and put this behind a comment so it's not actually trying to run it as JavaScript. So this is the end goal. We want to create the object with those properties, and we want to print a message to the screen that uses the name, the age, and the location inside. Then you're going to bump up the age. So you're going to increase age by 1 and print the message again. Like we did above, you're going to modify one of the object properties. In this case, you're going to increase the age by 1, and then you're going to print the new message. So it should say something like Andrew is 28 and lives in Philadelphia. Take as much time as you need to knock this one out, and then go ahead and actually test your work. Save the file and run the script. Make sure you see the message, then make sure you see the message with the age increased by 1. Pause the video, and when you're done, click play. All right, how'd that one go? Step 1 is going to be to create the object. So if we're trying to read and modify the object, it needs to exist. So right here, let, and I'm going to call this one me. You might have chosen a different name. And I'm going to set it equal to a new object. So I'm going to open and close my curly braces and hit enter right inside. In here, I'm going to define those 3 properties. First up, name, colon space. The name property is going to be a string. So I will open and close a single quote and type my name right inside. Next up, comma, the other property is age. Age, colon, space. Age is going to be a number, so I will store it as such. And the final property we're going to add, after a comma, of course, is the location. Location, and I'll store the location as a string. And for me, I'm just going to use Philadelphia, the city that I currently live in. Now, down below, we're going to kick things off by printing a message that uses those pieces of information. So console.log to print something. Then we're going to create a template string, and then we're going to inject those pieces of information, starting off with the name. So $ curly braces right inside. We're trying to read a property value. And remember, we use dot notation for that. We access the object. We then use a dot, and then we pick the property that we want to read. In this case, it is the name property. Now after the name, we're going to have space is space followed by their age. So $ curly braces, me dot age. After the age, we're going to have and lives in space. And the last thing, the period, is going to come just after the location. So right before that period, $ curly braces, me dot location. Now that we have this in place, we can go ahead and test our work. We can choose to run the program now, which I will, and just make sure things are looking correct. Andrew is 27 and lives in Philadelphia. Now what I wanted you to do was modify the age and then print this again, which means that we're just going to duplicate this line for the moment, although we'll learn how to break this out into a function in the next video. And right here between the two, we're going to try to modify the age. So we want to change me dot age, and we want to set it equal to some sort of age. Now we don't want to put a static value here like 99, for example. We want to read the old value and add 1 to it. So we're going to set me.age equal to me.age plus 1. So right here, we're taking the old value of age, we're adding 1, and we're storing it as the new value for age. In this case, I'm bumping myself up from 27 to 28. Now we can go ahead and remove the comments and test the final code. I'm going to save the file, rerun things from the terminal. Right here, I have Andrew is 27 and lives in Philadelphia. On the next line, Andrew is 28 and lives in Philadelphia. And there we have it. This was the goal for the challenge. If you're seeing these 2 messages, then you're all done. To recap, we now know how to do 3 things. We know how to define an object. We know how to read object properties, and we know how to change object properties. In the next one, we're going to continue looking at how we can use objects in this language by exploring how they relate to functions. I'm excited to get to that, so I will see you over there. Now that you know the basics of working with objects and their properties, in this video, we're going to figure out how objects work with functions. We're going to explore how we can pass objects in as function arguments, and we're going to figure out how we can return objects from our functions. To kick things off, let's make a new file for this video. In the objects directory, I'm going to call this one objects-functions.js. And in the objects functions file, we're going to start with a book. I'm actually just going to copy the my book object from the last video over to the new file. Then I'm going to create a second book by hitting enter a couple of times and pasting the book again. Now, all of the books in our fictitious application, they're going to have the same properties. All books have titles, all books have authors and page counts. It's not the properties that are going to change between the individual books, it's the values for those properties. So for this second book, let's change the variable name from my book to other book, and let's change those property values. So the title is no longer going to be 1984. For this one, let's use A People's History of the United States by Howard Zinn, and I'm just going to shorten that to A People's History. Now we also want to swap out the author. No longer is the author of this particular book George Orwell. It is now Howard Zinn, and the page count goes from 326 to 723. And now we have two individual instances of a book. All of them have the same properties. It is the values for those properties that differ. Now let's say we want to print that summary for all of the books I have. So we want to print the little message, the title, followed by the author. To do that, I would have to add a console.log for every book in my collection. This is going to create code that's duplicated over and over again. Instead of duplicating the code and writing a bunch of console.log statements, we're just going to create a function that accepts a book. It's then going to be able to use the book's properties to generate that message, which means we'll just have one console.log instead of one for every book. Down below, let's see what this is going to look like. We're going to make a function, and for now, I'll just call this one getSummary. We'll set it equal to a function, and this function is going to take just a single argument. So instead of needing to pass in title, author, page count, and everything else, we can just pass in the object because the object contains all of those values as object properties. Right here, that means we can accept just one argument in the object, and I'll call this book for our function. So how are we going to get access to book? Well, we're just going to call getSummary with the individual objects that we want to print the summary for, which means that down below, I can call getSummary with my book, and I can call getSummary with other book. In each case, I'm passing a book into the function, and now inside of the function, we can add the code that does whatever we're trying to do. In our case, we're trying to print that little message for the moment. Console.log, printing right here inside of template strings. We start with the book's title, book.title, then the word by, then the author, book.author. Excellent. We're able to pull both title and author off of book. Book is an object with those two properties. You'll notice I'm not directly referencing my book or other book. If I did, this function wouldn't be reusable because it would always be referring to the same book. But by just referencing the argument, the function is reusable. I can call it with as many different books as I like. Now let's go ahead and make sure all of this actually works by saving the file and running it from the terminal. Over here, node, objects-functions.js. I'm going to execute the file. I get 1984 by George Orwell and A People's History by Howard Zinn. This is fantastic. We were able to use this one line and do something for every single book that we have in the program. Now that you know how to pass an object into a function, let's figure out how we can return an object from a function. Now, why might you want to do that? Well, there are a lot of different reasons, but one good one is to be able to return multiple values. Right now, all of our return statements return just a single thing. For example, we return a single number, a single string, and in this case, a single string as well. If I want to return 2 strings, for example, or a string and 3 numbers, there's no good way to do that. But if we return an object, we can just add 3 properties onto it, and that's going to allow us to send back as many values as we like. Let's see what that would look like. Right here, we're going to add a return statement, and we're going to return an object. Now, yes, we could put that object on a variable up above, and then use return with that variable name, but we could just also define it right in line, which is what I'm going to do right here. Now let's say we want to return 2 variations on that book summary. I'm going to call this one summary, and I'm going to set it equal to the summary that we just generated. So I'll copy it and paste it up above. Then I'm going to add on a second property, a summary that includes that page count. Let's toss a comma on that line and then add right here, page count summary. I'm going to set it equal to, this is going to be a template string with a different message. We'll start off with the book's title, book.title. Then we're going to talk about how long it is followed by the page count. So right here, that would be book dot page count. And then after the page count, we'll just add pages long. So for this book, my book, it would say 1984 is 326 pages long. So using this object, we're able to return both variations of the summary from a single function. Now we can remove the console.log and figure out how this is actually going to work. Down below, this code isn't really going to do anything. Yes, it's going to execute the function, but we no longer have a console.log in the function, which means that we have to do something with the return values coming back. That's where the object lives that has our two summaries we can use. On this line, for example, I could say let book summary equal, and then I could do the same thing for the other one, let other book summary equal, and then we could do something with those summaries. So I could use console.log to print, for example, book summary dot page count summary. So we know that what comes back from get summary is an object, which means that book summary is an object. And in this case, we're just using dot notation to grab one of its properties. We can grab either summary or page count summary. I'm grabbing the latter. Now let's rerun the file and make sure we do get that message. I rerun things and I get 1984 is 326 pages long. So there we have it. By returning objects from functions, we're able to pass back multiple values, in this case, 2 strings, something that wouldn't have been possible otherwise. Now that we know how to pass objects into functions and how to get objects back from functions, let's move on to a little challenge. So down below, I'm going to create a challenge area where you're going to have to create a function that returns an object. Your challenge for this video is going to be pretty similar to what we did over in Functions 101, where you created convert Fahrenheit to Celsius. Though instead of just converting from one to the other and returning a single number, you're going to pass in Fahrenheit and you're going to convert it to both Celsius and Kelvin, returning an object that contains all 3 temperatures. So down below, create function, take Fahrenheit in, and then you're going to return an object with all 3. So you're going to return an object with Fahrenheit, whatever was passed in, with the converted Celsius value, and with the converted Kelvin value. If you forget the formulas, you should have all of them over in the basics directory. We have that temp conversion file that contains the 2 conversion formulas required. So take some time to create this function that returns an object with all 3 numbers on it, then actually call the function and dump the object to the console to make sure it has the properties showing up correctly. Pause the video, knock this one out, and when you're done, come back and click play. All right, how'd that one go? I'm going to kick things off by making my function. Let convert Fahrenheit equal a function. We're going to take in just a single argument. This is just going to be a number of the temperature in Fahrenheit. And we're going to return an object. So inside of the function, you needed to use return. You need to create a new object, and you needed to add on those 3 properties, Fahrenheit, Kelvin, and Celsius. Let's start off with Fahrenheit. That one's pretty easy. The Fahrenheit property gets its value from the Fahrenheit argument defined up above. Then a comma enter for the other property. The next one we can do is Kelvin. Kelvin is going to equal, right here, we're going to have the formula we had before. In parentheses, we take the Fahrenheit value, we add on 459.67 degrees, and then we take that and we multiply it by, in parentheses, 5 divided by 9. This is the exact same formula we had before. The last property we're going to add on to this object is going to be the temperature in Celsius. So comma enter Celsius. Right here, we add that formula into the mix. This time, in parentheses, it's Fahrenheit minus 32. We take the result of that operation and we multiply it by the result of, in parentheses, 5 over 9. Excellent. Now we have an object that's actually returning all 3 values, and we can call the function. I'm going to use convert Fahrenheit. I am going to pass in a value. Let's use 74 degrees. And then I'm going to do something with the object. So I could say let temps equal, and then down below, On the next line, I could just console.log temps, or I could have used dot notation to pull off a single value. For this case, though, this is going to get the job done. Let's save the file and rerun things over from the terminal. I'm going to rerun the script, and what do I get? I get my object back, and I have my temperatures. From 74 degrees, we go to 296 Kelvin and 23 Celsius, which is indeed correct. And there we have it. We have a good system for passing objects into functions and for returning objects from functions. This is going to make our function arguments a little cleaner. We can pass in just a single value instead of many values, and it's going to allow us to return multiple values, something we weren't able to do before. That is it for this video. We're going to continue learning about objects in the next one, so stay tuned, and I will see you then. In this video, I want to take a few minutes to talk about what happens when we pass objects around our program. For example, we take this other book object defined right here on line 7, and we pass it into the getSummary function. We do that down here on line 21. Inside of this function, we get access to the object as book, and we read a few of book's properties, title, author, and page count. We proved that this worked by running the script and seeing the various summaries showing the correct information. What I want to talk about in this video is what would happen if we were to try to modify book. Would we just be modifying book, the argument, or would we also be modifying that original object? To mess around with what happens when we do modify those objects, let's just create a new file and run through a couple of quick examples. Over here in the objects directory, I'm going to create a file called objects-references. .js, and in here we're going to start by creating an object. For this example, let's imagine we're creating an expense manager application. So the thing we're trying to model with our object isn't a book or a person or a car, it's the user's account in our application. So right here we can make our first account. Let my account equal, we're going to have it equal an object, and on this object, we're going to provide 3 properties for each account in our application. The first one is just going to be a name, something that we can use to identify which account we're referring to. Name can be a string, and I'll just use my name for this one. Now, the other 2 properties are going to be related to the expense tracking side of things, and the first one is going to be called expenses. This is where we're going to track the total amount of expenses the user has racked up. We're going to set expenses equal to 0 to start, and we'll change it over time. The last property we're going to add is the income. So right here, income will also start off at 0, and it's something that once again we'll be able to change with various functions we create. Now, to kick things off, what we're going to do is create a function that allows us to add an expense. So we specify the account we want to change, and we specify the amount of the expense. Let's say we buy a coffee for $2.50. In the end of the day, I would expect the expenses property of the account we're trying to change to be increased by that amount. To figure out how this works and to explore how passing around objects affects our objects, let's create a function. Down below, and I'm going to call this one add expense. Now, add expense is going to be a function, and it is going to take some arguments. It's actually going to take 2. As I mentioned a few moments ago, we need to know which account in our application we're trying to add an expense to, and we have to know the amount of the expense. So the first one could be something like account or user account, and the second one could be something like total or, in my case, amount. Now, it really doesn't make sense to have a default for either of these, so I'm going to go ahead and leave off default arguments for both. Down below, we can actually fill out the add expense function. What's the goal inside of here? The goal is to manipulate the expenses property of the object passed in. That is account.expenses. We are going to set it equal to a new value like we did in the previous videos. In this case, it is going to be the old value, account.expenses, plus the amount passed in. So here we get the current value, the current expenses, we add on the new amount, and we store that in the expenses property. Now, there's actually no need for this function to return anything. Its whole job is just going to be to change the account. Inside of here, for the moment, we're going to use console.log to print the account object, just so we can see how things are actually running in our script. And down below, we're going to use this new function. I'm going to call add expense. I'm going to pass in the 2 arguments it expects. The first is an account. I have just one, my account, and the second is an amount. Let's go ahead and stick with the example I used before. I buy a coffee for $2.50. Now what we're going to do to wrap up this little script is to log my account. So console.log my account. And this is going to allow us to see the differences between account and my account. Let's go ahead and save the file and run the script from the terminal. That is node objects references.js. And when I run the script, what do I get? Well, I actually don't get two different objects. I am getting the exact same thing printing twice. Right here I have an object, Andrew Mead 2.50. Down below I have an object with the same properties, Andrew Mead 2.50. So what exactly is going on to cause both of the objects to be the same? When we pass an object into a function argument like we do here, what we get as that argument value isn't just a clone of the object with the exact same properties and values, it's actually a reference to the exact same object in memory. So somewhere on your machine, in your computer's RAM, we have this object stored. My account is a pointer to this object. When we pass my account into add expense, account becomes a pointer to that object as well. And this explains why changing account not only changes account, as we probably expected, but it also changes my account, which we might not have expected. This is why we get an expenses value of 2.5 for each. Changing one is just like changing the other, since they're both pointing to the same object in memory. Now let's go ahead and play with this a bit more. What I want to do is comment out this line right here, and we're going to add a new line as the first line to the add expense function. Instead of manipulating one of account's properties, what I want to do is just assign something new to account. So account equals, using the assignment operator, something brand new. How about an empty object? Now the question is, what's going to happen here? Are we clearing account and my account? Are we clearing just one? So to figure out what happens, the best thing to do is to always run the program. I'm going to save the file. I'm going to rerun the script, and what we get now are two very different things. We're getting an empty object as the first console.log, that's the one right here, and we're getting an object with our my account properties as the second console.log. That's the one right here. So when we pass an object into a function, we can manipulate its properties. If we manipulate its properties, we're manipulating the properties of the object originally passed in. If we assign a new value to that argument, we break this binding completely. Now account does not point to the same thing that my account did. So I can't use the assignment operator in account to clear my account or set it to something new like the number 1. This is not going to work. It's only when we manipulate the properties of the object do we see the change reflected in both. So what we really want for the add expense function is something like this. We want to manipulate the expenses property, and there's not actually a need to log account. I just added that in there so we can see what's happening as the script runs. Now this behavior is not only for passing an object into a function. If I were to do something like the following, let other account equal my account, we now have the same situation where a change to my account would be reflected in other account, and a change to other account would be reflected in my account. The most common situation is to see an object passed into a function, but this would also create the binding. If I changed other account, I would see that change reflected down below. For example, other account dot income equals 1000. If I were to rerun the script, the very last console.log, actually the only one, the one for my account, reflects the change made to other account. So both of these are referencing the same object in memory. Now also, like what we saw before, trying to take other account and assign something new to it isn't going to change my account in any way. It's only when we change a property on other account will we see the change reflected in both. Don't get bogged down with the details too much right now. All of this is going to come up more organically as we start writing more code. In the very next video, we're actually going to have a challenge video where it's going to be up to you to add 3 new functions to the expense tracker. That's why there's no challenge for this video. The next one is a challenge video. I'm really excited to get to that one, so let's go ahead and jump right into it. I'll see you over there. Welcome back. In this video, we're going to be adding 3 new functions to our little expense manager. I said we, but I should have said you because this is a challenge video. You're going to be required to use what you've learned so far in the course to add these 3 new functions. Obviously, I am going to outline using comments what they should do at a high level, but actually implementing them and using them is going to be up to you. So let's start by outlining the 3 functions we're going to create. The first one is going to allow us to add income to the account, and I'm going to call this one add income. Add income is going to take the account to manipulate. Which account are we trying to add income for? And it's also going to take the amount of income we're trying to add. Down below that, we're going to have a function called reset account. A reset account, as the name suggests, is going to reset the expenses and the income for an account to 0. So it still needs to know which account to change, but that's the only argument it requires, since we're just going to use the static 0 for the values for both properties. The last one that you're going to be adding is going to be called something along the lines of get account summary. This is going to print a summary of the account that includes the current account balance, as well as the total in expenses and income. So an example of that would be something like the following. Account for Andrew has, right here, $900. That's the account balance. And then I could say 1,000 in income. And then I'd wrap things up with 100 in expenses. So if I had 100 in expenses and 1,000 in income, as reflected here, I would expect to have a balance of 900, and I'm also including the account name in the message as well. It's going to be up to you to run the balance calculation and get everything showing up in this string. You can return the string as the return value for get account summary, and then when you actually use it, you can just print it to the screen using console.log. So let's go ahead and outline what I'd like you to do in terms of actually using them. For example, we could add some income. Then we could add an expense, and maybe we add another expense. And then we could check our account with get account summary. Then we could reset things, clearing all of our balances, reset account. And then finally, we could get the account summary and print it to the screen again. So this is just an example of how you could use these functions down below to make sure they're all working as expected. It is important to actually use them because otherwise you're not sure if the code is going to run as it might look. If you have small misplaced characters, the program might fail. So take as much time as you need to add these 3 functions into the mix, then make sure to call them down below and test your work. If you get stuck, don't worry, we're going to move through the process together in just a few moments. Pause the video, and when you're done, come back and click play. All right, let's get to it. Up above, we're going to start with add income. This is going to be a new function, so let add income equal a function. We are going to set up the 2 arguments expected. The first one is the account to change, and the second one is the amount of income to add on. Now in the function, all we need to do is change one of the account object's properties. That's account.income. We're going to set it equal to the old value, account.income. And then we're just going to add on the income passed in. So here we take the old value plus the new one, and we store that as the income property value. That is it for the first function. We can now move on to the other ones down below. Next up on the list, we have reset account. Let reset account equal a function. And this function just needs one argument, the account, to reset. We don't need any other values as we're going to set both expenses and income to the static value 0. Right here, account.expenses equals 0. And then on the next line, account.income equals 0. Perfect. So the first 2 were pretty easy. Let's go ahead and move on to the last one. That is get account summary. Let get account summary equal a function. This function just needs a single argument, the account, to get the summary for. Right here, account. And then we're going to need to do a couple of things. We have to figure out what the account balance is, and we have to generate our little string that shows the various income, expenses, and account balance. Let's start by calculating that account balance. Let balance equal, we are going to take the total in income, so account.income, and we are going to subtract from it the total in expenses, account dot expenses. So if I had $1,000 in income and $200 in expenses, the final balance would be $800, which is correct. Let's go ahead and move on to the second line. Now, the second line is just going to be a return statement where we return a template string. It's fine if maybe you created a template string and stored it in a variable and then returned that variable. Either way gets the job done. Now we can start cranking out the various things for this one. Account for, followed by the account holder's name. That would be inside of curly braces, account.name. After the name has the $sign, and then right here we inject the bounce. So that would be the bounce variable. Then we add a period, and we move on to the income. So $sign, then $sign curly braces to inject the income. That would be account.income. Spelled correctly, of course. In income, and the final sentence is going to be related to the expenses. So a $sign, then a $sign curly braces to inject the expenses, account.expenses. And then finally, we wrap it up with the last bit of static text, in expenses, period. Excellent. So we have all of this in place. We have all three functions set up. The last thing to do was to actually use them and make sure they work. And I gave you an example as to how you could do that. You could have used a different series of function calls. That would have been perfectly fine as well. I'm going to start by adding some income to my account. I'm going to add income to the account stored under the my account variable, and I'm going to go ahead and start them off with $2,000. Then I'm going to add a few expenses. So add income, expenses, add expenses. I'm going to add an expense to my account, and I will add an expense of $2.50. Let's say I buy a cup of coffee. Then below that, we'll add another expense. So we call add expense again, and we provide the account we're trying to manipulate and the expense value. Let's say for this one, we buy something more substantial. Let's say some utility bills come in and we pay $160. Now we have some income and we have some expenses. We can make sure everything is working by using get account summary. So console.log, we're going to call get account summary right here. And we're going to pass in the account we're trying to get the summary for. So this code right here is going to return the string. We're passing the string to log, and the end result will be it printing to the screen. And we can actually start here. There's no reason to add the rest just yet. Let's go ahead and run the program and make sure things are working so far. We're going to rerun that script. That is node objects references.js. When I do it, I get account for Andrew Mead has $1,837.50, $2,000 in income, $162.50 in expenses. This is indeed correct. Everything is looking real good. Don't worry just yet about the formatting, the missing 0 right there, for example, and the lack of a comma here. We'll get to that a bit later in the course. For now, we have the basics in place though. Everything is working really nicely. Let's go ahead and wrap things up with the final two calls. The last one is just a duplicate of this line where we print the account summary. So I can copy it and paste it down below. And the second to last one is just a resetting of the account. So reset account. And we pass in the account to reset. My account. Excellent. Let's go ahead and delete all of the comments down below and actually run this thing for the final time. Over here, I'm going to rerun the script and we should get two summaries. The first one is exactly what we had before, and the second one says account for Andrew Mead has $0, 0 in income, 0 in expenses. Everything is working really, really nicely. We have our 4 functions in place, and these 4 functions are allowing us to manipulate my account. Now, once again, for the moment, as we learn JavaScript, we're just exploring all of this in little scripts. But imagine that adding an expense was done via a button click of a form, and the same for add income and reset account. And you could also imagine that the value that comes back from get account summary is shown to the browser. These are all things we'll learn how to do later. For now, we're just focusing on exploring how functions and objects work together because it's something we do so often in JavaScript. With this in place, we are all done for this video. We have our little expense manager project all set up, and we're going to continue on to the next one, learning more about objects. I'm excited to get to it. I'll see you then. All the objects we've created so far in this section have had pretty standard property values. We've added on things like strings, numbers, and booleans, but we can actually add functions as property values as well. We're going to explore exactly how we do that and some additional features given to us when we do. Over in the objects folder, let's make a new file for this one. I'm going to call this one objects-methods.js. We'll talk about exactly what a method is in just a second. Before we do, let's go ahead and create an object that we can add a function onto. Let's create a little restaurant seating tracker that keeps track of how many guests we currently have, so we can figure out if we can seat a party of a certain size when they walk in the door. So if 5 people walk in, I want to be able to quickly figure out if I have 5 seats available to them. So the thing that we're going to model with our object is going to be this restaurant. Let's make a new object called restaurant. Restaurant is going to be an object. And on here, we're going to add a few standard properties, values who are strings and numbers. Let's start off with the restaurant's name. You can pick any one you like. I'm going to use ASB, a restaurant near me. That stands for American Sardine Bar. And then what I'm going to do is go ahead and add 2 others, specific to tracking the total number of seats available and the total number of seats being used. So the first one we can call something like guest capacity. Let's say that the guest capacity for this restaurant at any given time is 75 guests. We're also going to track the number of seats currently in use. We can use guest count for that. So if we just opened for the day, we would say that we have 0 guests sitting. So at this point, we have 75 available seats to us. Now, imagine we want to quickly create a function that takes in a number and figures out if we can seat a party of that size. So if I pass in 5, I would figure out if I can seat 5 people by taking the guest capacity, subtracting the guest count, and figuring out if that number is greater than or equal to 5. In this case, 75 minus 0 is greater than or equal to 5, so I would be able to seat a party of 5. Now, there are a few ways we could get that done. I could define a new function down below, much like we did over in the object references file. I could take in the restaurant and the number of people who are trying to be seated, and I could run the calculation and return true or false, depending on whether or not we had enough seats available. But what we're going to do is play around with methods. A method is nothing more than an object property whose value is a function. So if we want to create a new method right on here, we just add a new property on. We pick a name for it. I'm going to call this one check availability. Check availability is going to figure out if we can seat a party of a certain size. Now for the value, we're not going to use a string, boolean, or number. We're going to create a brand new function. So we use the function keyword. We add our arguments list and we add our function body. And now we have our very first method created. Remember, a method is just an object property whose value is a function. In this case, the object property check availability does indeed have a value of a function. Let's go ahead and make this function actually do something. This one's just going to take in a single argument, the party size. So how many people are we trying to seat? And for the moment, we're not going to really calculate anything. We're just going to dump party size to the console to make sure the function actually runs. Console.log, passing in party size. Now the question has to be asked, how exactly do we call check availability? Well, you've actually already done it just with different methods and objects plenty of times before with console.log. Console is an object available to us by JavaScript. Log is a property who's a function, so you could call it a method, and it takes in the thing you want to dump to the console. So in our case, if I want to call check availability, I have to first get to that property, restaurant, dot check availability. Then I have to pass in, calling it as a function, the party size. Let's just say for now it's me and 3 friends, so the party size is 4. I want to figure out if I can seat 4 people. Let's go ahead and run the program and see what happens. I'm going to save the file and from the terminal run this one, node space. The file is objects-methods.js. When I run the script, what do I get? I get 4, and that's great. That means we were able to successfully call our method check availability with the argument 4, and the function actually did its thing. It went ahead and printed it to the screen. Now, the real check availability method isn't going to actually dump anything to the console. It's going to run a little calculation and return a boolean. True if we can seat a party of that size, and false otherwise. So let's play around with this. I'm going to start by messing around with just the return value. I'm going to return true, and then we are going to access it and print it. So down below, let status equal whatever comes back from the check availability function call. Then down below that, console.log status, printing the status to the screen. This is going to allow us to figure out if we can seat that party. Now, right now, it's always going to be true, but I just want to make sure things are still working with the return value in place. So at this point, we can take an argument and we can return a value, and this is what we've been able to do so far. So what's interesting about putting a function on an object? What's interesting is that you get access to that object's properties right inside of the function. That means we can access name, guest capacity, and guest count from inside of this function, and that's going to allow us to do things like run our little calculation. To access the object properties, we use what's known as the this keyword. The this keyword is a source of a ton of confusion for new developers. It's a place where a lot of people get tripped up, so we're going to break it down into a way that's easy to understand. Inside of our methods, we have access to this. This references the object the method is defined on. In this case, we have our method right here. What object is it defined on? It's defined on this object. So this refers to the object. Now that means we should be able to console.log this to see the object with all of its properties. Right here, console.log this. I'm going to save the file and rerun things. And what do we see? We see an object with all of those properties: name, guest capacity, guest count, and check availability. That's it. That's all we have to worry about related to this at the moment. It's a way to access our object properties inside of a method. So we can access, for example, this dot guest capacity. And I actually spelt it wrong. It should be I-T-Y, not T-I-Y. Now we're accessing the individual property, and if I were to rerun things, I would expect 75 to print, and that is exactly what happens. So using this, we're going to be able to get the guest capacity and the guest count and actually figure out if we have enough seats available. Let's go ahead and do just that by creating a new variable right here. Let seats left equal, and then we're going to access those two properties, subtracting one from the other. So that is this dot guest capacity minus this dot guest count. In this case, the value would be 75, and we would be able to see that, yes, we can seat a party of 4. Now, how do we actually create the Boolean? Well, all we do, instead of having a static true, is use the comparison operator. We're going to check if the party size is less than or equal to the seats left. If it is less than or equal to the seats left, we can seat them. If it's not less than or equal to the seats left, we would be unable to seat them. Let's go ahead and save the file and see what happens. If I rerun the script, I would expect to get true, and I do. Now let's go ahead and change the guest count. Let's say we have 73 people already in the restaurant, so we only have 2 seats left. If I rerun things, what do I have this time around? I get false. So using methods, we're going to be able to add functionality right onto the object itself. We can get arguments, we can return values, and we can also use this to access properties off of the object the method is defined on. Let's go ahead and reset the guest count to 0, because instead of just changing it on the object, we're going to change it via method calls. So down below, there are 2 new methods we're going to be adding on to the object alongside of check availability. The first one would be something like seat party, which takes the party size to be seated and adds that on to guest count. The other one would be something along the lines of remove party, which would take the party size that's leaving the restaurant and it would remove it from guest count. Now, you're going to actually create these 2 methods as your challenge for the video. I'll go ahead and actually add the usage down below. So we could do something like restaurant dot seat party. I could seat, like, let's say 72 people. That would mean that I don't have room left for 4. Let's go ahead and simplify these 2 lines by just taking this method call, cutting it out, and dumping it right inside of the parentheses for console.log, removing the need to actually create a variable. So we try to seat a party of 72. That's going to work. We check the availability for 4. That's going to fail. Let's go ahead and remove some people. Restaurant dot remove party. Let's say we remove a party of 5, so then we would have 4 available. We can just take this line, copy it, and paste it down below. So this is what I want you to do. I want you to create the seat party and remove party method to make this code actually work. I should see false for this one, and I should see true for the one down below. Take as much time as you need to get this one done, create those 2 methods alongside of check availability, and then test your work. When you're done, we're going to go through the process together so you can come back and click play. Pause the video, and I'll see you in a second. All right, how'd that one go? To kick things off, I'm going to create the seat party method. So right inside of our object, after this property, comma, enter, the next property, seat party. It's going to be a function. Is this function going to take any arguments? Yes, it's going to take the party size that we're seating. Party size. And all it's going to do is add this party size onto the guest count. That is this dot guest count. So we're going to set this dot guest count equal to the old guest count, this dot guest count, plus party size. Excellent. That's all we have to do for the seat party method. The other method you needed to create was remove party. So comma, enter, remove party. This one is also going to be a function that also takes as its one and only argument party size. This time though, we're going to be subtracting the party size from the guest count. So this dot guest count is going to equal the current guest count, this dot guest count, minus the party size passed in. Whoops, accidental enter. Excellent. That's all you had to do to create those 2 methods. We can go ahead and remove the comments and actually test our work. I'm going to save the objects methods files, use clear to clear the terminal output, and the up arrow key twice to rerun the objects methods file. When I do, what do I get? I get false for the first and true for the second, which is indeed correct. If I seat 72 people, I only have 3 seats left, which means I can't seat 4 people. If I remove 5, I have 67 seats left, which means I can then seat 4 guests. So there we have it. By using objects and methods, we're able to create a self-contained unit where we have the functionality, our methods, stored right alongside of the data that they work on. And this is something that we're going to see quite a bit, not only in code we create, but in various objects and methods that are provided to us by the language. Methods and objects come up a bunch in JavaScript. There are a lot of them that are available to us, built right into the language. And now that we know that methods exist, we can start exploring more than just console.log. We're going to continue on in the next section, the next video, so stay tuned and I'll see you soon. In this video, we're going to continue talking about methods in JavaScript, but instead of creating and running methods that we've written, we're going to focus on exploring some methods made available to us by JavaScript itself. So in the last video, we created some data. The data modeled a restaurant, and all of the methods we created worked with that restaurant data. In this video, we're going to explore the string and all of the methods available to us to work with the string data. Imagine, for example, we're trying to validate a user's password, and we want to make sure that its length is greater than 8 and that it doesn't contain the word password. Right now, we don't have a way to do that, but with string methods and properties, we'll be able to do just that and more. I'm going to create a new file in the objects folder, and I'll call this one string methods.js. And in here, we're going to start off by adding a string. We needed some string data to work with. Let's make a new string, and we'll just store our name inside of there, something simple. We'll keep the string simple since what we're going to explore can be a little complex. The first thing we're going to do is explore a property on our strings called length. And as the name suggests, it returns the length of the string as a number. So in my case, how long is this string? We got 6 plus 4 plus the space for a total of 11. Let's go ahead and figure out how we can figure out the string length. Right here, length property. And down below, first up, we have to reference the string. So we have that stored under the name variable. And then we have to access its length property. So we use dot notation, dot length to get the property. It's not a method, so we don't add parentheses on there. It's a property. So we just grab the data, much like we grabbed the data over here, using something like this dot guest capacity. Now, at this point in time, yes, we are getting the length, but we're not doing anything with it. Let's go ahead and dump it to the terminal. I'm going to add a closing parenthesis at the end, and up front, I will toss console.log with the opening parenthesis. Now we should be able to save the file, run it, and actually get something meaningful printing. Over in the terminal, I'm going to run this new file. That is node string-methods.js, and when I run it, what do I get? I get the number 11 printing right here. If I were to change my name, removing my last name, save the file and rerun it, I would see the new length, which is 6. So using the length property, we'll be able to do things like validate a user's password. Does the password contain 9 or more characters, for example? Now that we've seen one of the properties, let's explore one of the methods. Down below, I am going to add Mead back on, and we're going to figure out how we can convert all of the characters in our string to uppercase. To do this, we use a method right here, convert to uppercase. I'll show you where the documentation lives for all of this in just a second, but down below, what we're going to do is access this method. It is name dot, since we're accessing something on our string, and this method is called to upper, capital U, case, capital C. Now this is not a property, it's a method, so we have to call it as such, and it doesn't take any arguments. All it does is it takes your string, it converts it to uppercase, and it returns that as the return value. So it's not going to change the name variable, it's just going to give us a new string that we could store, or in our case, we could just print it to the screen. So right here, closing parenthesis, and up front, console.log parenthesis. I'm going to save the file and rerun things. And what do I get? I get a length of 11, which is correct, and I get Andrew Mead being screamed at me from the terminal. So this is just a quick preview of how we can use string methods and properties. Before we go any further though, I want to make you aware of where the documentation lives for all of this because it's super important. Now I believe the documentation is really essential for learning a language. Getting comfortable with it is going to allow you to explore all of the features available. But at this point in the course, it's also going to open up some questions because some things you'll see in the documentation won't make sense yet since we're not done with the course and we haven't explored all of the features of the language. So let's keep that in mind as we explore the documentation. While some things will be clear, others will be a little bit blurry. To find the documentation for the string, we're going to go over to Google and search MDN, which stands for the Mozilla Developer Network. It's the best set of documentation for JavaScript. And then I'm going to toss string on the end. And this should get me to the right place. We're looking for the string page at the developer.mozilla.org website. Down below, you can see some other methods available to us that we'll explore later, but for now, we can just go to the main page. The main page is going to contain some information about the string in general. And if we look at the examples over here, we can see they're creating a string just like we've done in the course. We got single quotes, we got double quotes like we've talked about. What I want to focus on this page is what's on the left-hand side. Under properties, we can see one of the properties we've already explored, the length property, and under methods, we have a list of all of the methods available to us, and you can see that that list is pretty extensive. If we scroll down a ways, down to T, we can see the one we just used, to uppercase. And if we actually click this method, it'll take us over to the method documentation where we can see how we use it. We call to uppercase on a string, we pass in no arguments, and then it talks about what comes back. A new string representing the calling string converted to uppercase. So being able to navigate the documentation is going to go a long way towards actually remembering how things work. You're not going to remember all of the methods we talk about in the course, but if you can navigate the documentation, you'll be able to find them and jog your memory in just a few moments. Now we're going to use the alternative to uppercase, which is to lowercase. This does exactly what it suggests. We could click over there if we wanted to, but let's just switch back to the terminal and Visual Studio Code to test things out. Right here, convert to lowercase, and this one is super easy. We are going to use console.log to print something, and much like the method up above, it is just our string dot to lowercase. And the case of the method does matter. So you got to make sure to match up the casing correctly with the documentation. Otherwise, the method isn't going to exist and you're going to get an error when you try to run your script. We can save this. I can run things over from the terminal, and you can see now we have things in lowercase, the A and the M being in lowercase as well, even though they weren't in the original string. Now, these are all great, but they're not the most interesting methods in the world. One that is super useful is the includes method. We can explore that in the documentation as well. We scroll up to I. Up here, we have includes sitting right here, and we could even click over to the documentation for this one to take a look at some documentation for a method that actually does take arguments. So right here, we can see the includes call syntax. On a string, we call includes, and then it's talking about the potential arguments, and down below, it actually lists out what they are and what they expect. So the first one, a string to be searched for within this string. So imagine I have the password, it contains the characters ABC123, password 098, and I want to see if it contains the string password, which it does. We could use the includes method to get a Boolean back, true if it includes it and false otherwise. Now you can see down below exactly what I just said. Let's go ahead and mess around with this one over in Visual Studio Code. Over here, let's create that password. First includes method. Let password equal, I'll call this one ABC123 password 098. And then down below, we're going to use the includes method. That is password, our string, dot includes to access the method, and then we're going to go ahead and pass in the argument it expects. The second argument isn't really necessary in this case, but the first one is required. It's the thing we're searching for. Let's say we want to make sure the user has a strong password by not having password directly inside of it. So we're going to see if it does. This will return true if it contains it, which it does, and false otherwise. Let's go ahead and log this value to the screen. Console.log. I'm going to switch over to the terminal after saving things and rerun the script. What do I get? I get true printing, letting me know that the password probably contains things that it shouldn't, and we will be able to get this information back to the user and tell them to enter a stronger password. If we were to change the password to something else, let's go ahead and get rid of password and replace it with some random characters, and then rerun the script. This time around, we would get false, since the original string right here doesn't contain this string inside of it. So now that we've seen the includes method, there's just one more method I want to explore to give us a taste of what we can do inside of strings. Down below, this method is called trim. The trim method allows us to remove extra white space from a string. So imagine we have a form in the web, something we'll have later, and the user enters their name, but they accidentally had a few spaces before or after it. Now, these spaces can be hard to see in the form, especially if it's after it. They're basically impossible to see in the web browser. But if we were to save this data, we really wouldn't want to save it with those strings on either end. So what do? Well, we can trim out all of that extra space using the trim method. Once again, we can explore this in the documentation to figure out how it works. We scroll down to the list, get into T. Down here, we have trim. We click it, and we can figure out exactly what it does. So here we see another method which doesn't take any arguments. We just call it, and it does something. What does it do? It returns a new string, representing the calling string stripped of white space from both ends, both the beginning and the end. Let's actually use it and see if it works as advertised. I'm going to switch over to the terminal, over to VSC, and I'm going to call this method, console.log. And in this case, I'm going to go back up to the name string as opposed to the password string. That is name dot, right here, trim, calling it as a method, but with no arguments since it takes none. Then I can save the file, switch over to the terminal, run things, and what do I get? Right here, you can see I get the string with the spaces on both ends, but after I trim it, you can see that the extra spaces have been removed. So this is really useful when it comes to sanitizing data that users enter. So when a user enters data, we want to make sure it is correct. One of the things we'll be doing is removing those white spaces. So obviously there are other methods available to us on that list. We got about a dozen we haven't explored, and we will get to most of those, but these are some of the quick hitters that are going to allow us to figure out exactly why using something like built-in methods would be useful. It allows us to do things we couldn't otherwise do. Now that we've taken a quick peek at these methods, I want you to use a couple of these together to create something meaningful. It's going to be your job down below, and I'll create a little challenge area just for you. What I'd like you to create is a function called isValidPassword. And as the name suggests, this is going to be a function that validates a password. So it'll take a single argument, the string password, to validate, and it'll return true if a password is valid and false otherwise. Now, what criteria are we going to use? Well, what I'd like you to do is only return true if the length is more than 8. So 9 characters or greater, and it doesn't contain the word password. If it meets both of those standards, then we can return true. If it doesn't, then I'd like you to go ahead and return false. Down below, I'll give you some example usages. Console.log. We'll call this new function isValidPassword, and we'll pass in the string we're trying to validate. For this one, let's say it doesn't meet that length criteria. I'll just put in a few characters. Then we can duplicate this line a couple more times. For this one, let's go ahead and say that it is a valid password. Let's use ABC123 with a couple of special characters. And then for the last one, we'll have a nice long password, but we'll say it does contain the word password. So here we have 3 situations. This one will fail because of the length. This one will pass because it's valid. This one will fail because it contains the word password. So to know if you got it right, you should see true, false, and then true. Take as much time as you need to knock this one out and use what you learned up above to get it done. You're going to have to combine 2 of those and then test your work. Make sure that if you actually run the file, you get the expected results. Pause the video, and when you're done, come back and click play. All right, how'd that one go? Hopefully you were able to knock that out without too much trouble. I'm going to start by making our new function. Let isValidPassword equal a new function. Does it take an argument? Yes, it does. It takes the password. I'm going to call this password. Now inside of the function body, we're trying to do a couple of things. First, we're trying to validate the length, and then we are trying to check if it contains the word password. There are a ton of different ways you could have got this done. Let's go over a couple. Well, let's start off with a solution that uses an if statement. So if, and then right here, we're going to add our 2 conditions. The first one, we want to make sure the password.length is greater than 8, so 9 or more. And so we're going to use the logical AND operator. We want to make sure it doesn't include the string password. So we're going to use password.includes to check that. I'm going to pass in as the one and only argument the string we're looking for, password. Now we'll notice that this is going to be the opposite of what we want. This is only going to return true when the string is in there. We want it to only return true when it's not there. So as we explored previously, we can use the logical not operator to flip that Boolean. Now we have an if statement that's only ever going to run if the password is valid. So what do? We return true. If it's not valid, we can use our else clause right here to return false. And there we have it. This could be one way to tackle the problem. Over in the terminal, we can now rerun the saved file, and what do we get? We get false, true, false, exactly as expected. It is correctly validating our password against those 2 criteria. I'm going to remove the comment, and we'll explore one more way to get this done. If you ever find yourself in a situation where you have an if statement like this, if condition return Boolean, else return the other Boolean, you can always simplify it. So this right here already resolves to true. So there's no need to have the condition and then return true. We can just return this expression exactly. To prove it, let's take it and cut it out exactly as we had it before and remove the if statement. Then all I'm going to do is return whatever we had. If the password is valid, this will resolve to true. If the password is invalid, this will resolve to false, which we already proved with our if statement solution. So now we can save things, we can rerun it, and we can see that our one-liner function works exactly the same as the other function did. Here we are still getting false for this one, true for this one, and false for the final password. So there we have it. In this video, we took a quick look at the various methods available to us on our string. There are more. We'll explore those as we move through the course and actually need them to solve specific problems. But for now, we have a pretty good taste of exactly what we can do with those methods. And if we want to explore new ones, we have the documentation available to us. That's where we're going to stop for this video. Sorry, this one ran a little long. In the next video, we're going to take a look at some more built-in stuff, but in that one, we'll be focusing on numbers. I'm excited to get to it, so stay tuned, and I'll see you then. Now that you've explored the string and some of its methods, let's take a look at the number and some things that it allows us to do. I'm going to do this in a brand new file. First up, let's go ahead and close all of our currently open files to simplify things just a little bit. And right here in the objects directory, we can call this one number-methods.js. And we're going to start by creating a number to work with. Let num equal, and you can pick whatever number you want. Just make sure we have some decimal places in it. I'm going to go with 103.941. Awesome. Now down below, let's start messing around with the methods we have on our numbers. With numbers, there are infinitely less useful methods available to us. There's just not that much going on since most of the math operations we do are done via the operators we already explored. One great one, though, is the toFixed method. This allows us to specify the number of decimal places we would like to preserve. We could specify 1 to just keep the 9 or 2 to keep 9-4 and have it look a bit more like formatted currency. Let's go ahead and explore this. We'll use console.log to make sure whatever work we do actually shows up somewhere. And in here, it is num.toFixed. The toFixed method takes a single argument, a number of digits you want to keep. 1 for 1, 3 for 3, or in our case, we could just keep 2 digits to keep things looking similar to a currency. Now that we have this in place, let's go ahead and move into the browser and run this file and see what we get. That would be node number methods.js. When I run it, what do I get? I get 103.94 showing up. Here we were able to customize the amount of decimal places. I could trim this down to 1 if I wanted to just see the first one. Right here, I just get 9, or we could crank it up to something big like 10, in which case it would just add on some zeros. Right here, we get that number showing up. Using toFixed is one of the handy methods. As I mentioned, there really aren't many more that we're going to find ourselves using throughout the course, but I will show you where the documentation lives. In the browser, that is mdn number, and the result we're looking for is this first one, the reference for the number. And once again, we're just going to focus on that left-hand side table of contents. Now, all of the properties for the number aren't particularly useful. I've never used any of these when creating an application, either for myself or for others, even if that application was data intensive. Down below, we have some of the methods available to us, like the one we just explored, toFixed sitting right here. As you can tell, there are quite a fewer methods available for the number than for the string. Now, with the number, we don't just have the number itself to explore. There's also a math object made available to us, which has other things that allow us to do things with numbers. Let's explore that as well. MDN math. The math global is available to us in our script, much like console is. We don't have to do anything in order to get access to it. It's provided to us by the language. Here on the left-hand side, if we go down to the methods, we have quite a few different math-related methods. For example, we have one that allows us to round a given number. Down below, we have round. We also have one for generating a random number, for squaring numbers. All sorts of math-based operations live on this math object. Let's go ahead and take a quick moment to just mess around with a couple of them to see how it works. I'm going to switch over to the terminal and then back over to Visual Studio Code, and we'll use one of these down below. Let's go ahead and start with that round method. So to access math, we use uppercase math, and then we access methods on it, like console.log. So math.round. Now round takes the number that we actually want to round. So we're going to pass in the num variable up above. And in this case, it's going to round it. Since we are already at 0.9, it's going to round it up. If we were at 0.4, it would have rounded it down. Let's go ahead and actually print this guy so we can see the result. Up front, console.log, wrapping everything in parentheses, opening and closing, and then rerunning the script from the terminal. Right here, we get 104 printing to the screen. We're rounding up from 103.941. Now we can also force it to go in one direction or another. So let's take this line and duplicate it a couple of times. I'm going to add it twice down below, and we'll look at two other methods available to us. One is math.floor. This forces us to round down to the nearest integer. So that would give us 103, and its counterpart is the ceiling method, which is shortened to CEIL. This forces us to always round up, even if we were at a number like 1.1. Now, if we were to run the script, we could see those two results showing up. Right here, we get 103 for floor and 104 for ceiling. Now, there are other math operators for more complex things. If we were creating some sort of math-based calculator, we could do things like calculate tangents and all sorts of interesting things like that. But for most of our applications, as you're going to find in programming, the math really isn't that bad, unless you have some sort of math-specific application. If we're trying to create a new social media application or an e-commerce store, the most complex math we have is probably adding a few numbers and incrementing things by one. It really isn't too bad. Well, there's just one more method I want to explore before we go, and this is the math.random method. This is a popular one for generating a random number. Imagine I wanted to generate a random number between 0 and 10. I would use math.random with a few other math operators to get that done. So math.random generates a number between 0 inclusive and 1 exclusive. So what exactly would that look like? Well, let's go ahead and run it to see what I'm talking about. Over in VSC, let random num equal, we're going to use math.random, and as we saw, we don't need any arguments, we just call it, and we get the random number back. And then we log it, console.log random num. So this is going to generate a number between 0 and 1. So if I run it, what do I get? I get 0.1408 with a whole other bunch of numbers after it. I run it again and I get a different number. So this number could go from something like actually 0 to something as great as 0.9999999. Now that's not particularly useful since we usually want to generate a number between two numbers, like between 0 and 10 or between 0 and 100, something along those lines. Well, using math.random with some of the other things we just explored, we can actually get that done. So let's explore this. This is going to get a little complex, but it's a useful thing to be able to do. Right here, we're going to define two variables, min, let min equal, and max. We'll set the min equal to 10 and let max equal 20. So let's say we're trying to generate a random number between 10 and 20 for our game or for our application. There are a lot of great use cases for generating some sort of random number in a specific range. Now we have this number, the parameters set up. Let's go ahead and actually use them to create a formula that's a little more meaningful. Because remember, right now, random num is going to be between 0 and 0.99999. That's not what we want. We want it to be between 10 and 20, and we want whole numbers only. So I don't want to be able to get 11.34, for example. To get that done, we use a pretty common formula. We're going to see this throughout the course. We'll explore it now, and then we'll use it over and over again anytime we actually want to create something random. We multiply math.random, that value, by the max minus the min. So max minus min, what's that going to give us? That's going to give us 10, which means now we're going from 0 to whatever 10 times 0.9999999 is, which would be 9.9999999. So now this is the range we're working with. What we're going to do from here is add 1. So plus 1. And if we visualize that, it would now bring us up from 9.99999 to 10.99999, repeating. Now this still doesn't really get us what we want. We're going to take things one step further by putting an opening parenthesis here, a closing parenthesis here, and then at the very beginning, we are going to use math.floor. We're using math.floor to convert this potential decimal down to a whole number. So what's the new range? The new range is from 0 all the way up to 10, since we're converting 10.99999 down to 10 itself. So now we have a situation where we're getting whole numbers between 0 and 10, but we wanted it between 10 and 20. So what do? We take that and we add the min on. And there we go. This formula is a little complex, but it is going to allow us to successfully generate a random number between two numbers. By adding on the min, we go from 0 to 10, and we go from 10 to 20. Let's go ahead and see this in action. I am going to save the file and rerun things. Right here, we get 20, then I get 19, then I get 12, I get 12 again, I get 17. And if we were to change the input, we could see that work as well. Let's do a random number between 0 and 1. So that's like flipping a coin. 0 heads, 1 tails. I'll run it a few times. We get 0, we get 1, 0, 0, 0, 1. So using this formula, we'll be able to generate a random number. Now it's challenge time. You're going to go ahead and use what we learned about generating a random number to actually create a little guessing game. So I'm going to remove some lines, and down below, we'll add in a challenge area. And your job is to create a function. The function is going to take in the person's guess, a single argument. It's then going to generate a random number in a given range and figure out if their guess was correct. So for us, we could say the range is between 1 and 5. And if the guess is correct, we'll return true. So true if correct, and then false if not correct. Whoops, F-A-L-S-E. Now, example usage might look a little bit like this. Console.log to print the result. We could call it something like make guess, and we could pass in 1. So if the random number is 1, then I would get true back. If it's not, I would get false back. Once you actually create this little guessing game function, just run the program a few times. Make sure you see false a few times, and then make sure you also eventually get true when your guess is actually correct. And you can just repurpose the code up above. You can cut it out from up here and move it into the new function that you create. Take some time to knock this out, pause the video, and when you're done, click play. All right, how'd that one go? Hopefully you were able to get that done without too much trouble. Let make guess equal a function. We're going to take in the user's guess. I'll call this one guess. And then we're going to set up the function body. Does it make sense to have a default here? Not really. We want to actually take the guess in. Now, what are we trying to do inside of this function? Well, we're trying to generate a random number. So I can take this code from up above and repurpose it. I'm going to copy and paste it in. And then I'm going to adjust the range. So for this game, I said a good minimum would be 1 and a good maximum would be 5. Now we have the random number generated, and all we need to do is figure out if the guess equals the random number. Now remember, we could use an if statement, and then we could return booleans in the if statement code block, but we can also just return our comparison operator. So right here, I can check if guess equals random num. If this is true, if they equal each other, the returned true will be the case. If they don't equal each other, this will resolve to false, and we will see a return value of false. So once again, this is the one-line equivalent, much like we explored the one-line equivalent in the last video. Now that we have this in place, we can actually test out our little game. Over in the terminal, I can run the program a few different times. I should get false most of the time, but if I run it enough, at some point, I should get true. And there we go. I just got true right there. Apparently, the random number generated was indeed 1. And you can imagine that later on, when we actually know how to connect JavaScript to the browser, we could have the guess come from user input, and we could display whether or not they got it right to the actual browser window. For now, as we explore the basics, we're still just sticking with these script files. So that's where we're going to stop for this video. We learned about string methods in the last one and number methods in this one. There's just one more small topic I want to cover before we wrap this section up. In the next video, we're going to talk about a different way to define variables in JavaScript. I'm excited to get to it, and so let's go ahead and dive right in. In this video, I want to wrap up our section on objects by not really talking about objects too much. Instead, we're going to talk about an alternative way we can define variables in JavaScript, an alternative from what we've been using so far, which is the let keyword. To explore this alternative, let's go ahead and create a new file in the objects folder. I'm going to call this one const, which is short for constant. That's const.js. And in here, let's start with an example creating a let-based variable. Super simple. Let is raining equal true, and then we'll say at some point later it stops raining, so we can assign a new value to is raining. I'll set it equal to false, and then maybe we print the status, whether or not it's raining. So console.log is raining. Based off of what we've covered in the very first video, we should know that the value that's going to print would be false. If I run the script, node const.js, that's exactly what we get. We started off with true, we reassign to false, and we get false when we print it. This is with a let-based variable. There is another way we can create variables. Instead of using let right here, we use const. The rest is the same. We still provide a variable name and we still assign it some value, whether it's a string, boolean, number, object, function, or anything else. The only difference between let-based variables and const-based variables is that you can't reassign a constant after it has been created. So right here, we create our constant. Right here, we try to reassign it. This is illegal with constants. We can prove it's illegal by running the script. I save the file, I rerun things, and what do we get? We get a big old error message, type error, assignment to constant variable. We can see exactly where this is occurring. It's on line 3 of const.js. Line 3 is sitting right here. Now, if we were to comment out this line and run the script, things would work as expected. We give a value to is raining, and later on in the program, we reference it. If we rerun the script, we can prove it still works. We see true right here. Now you might be wondering, why is this useful? It doesn't make much sense to create a variable if we're never going to reassign it, but look at a lot of the programs we've written so far. For example, in this file, we create num, min, max, and random number. At no point do we ever reassign any of those. And if we crack open one of our other files, let's say something from functions like function scope, we can see we create a variable here that we don't reassign, we create one here that we don't reassign, and we create two down below we don't reassign either. So there's a lot of situations in software development where we're trying to create a variable and we know we're never going to reassign its value. In that case, it is best to use a constant over a let-based variable. Now, it's important to remember that this only applies when we're trying to reassign a variable's value. Imagine our variable was an object. I'm going to switch is raining over to person, and we'll make this a very simple object, an object with a single property age set equal to our age. Now this is a constant, which means that we still can't reassign its value. So if I tried to set person equal to a new object, that would fail. I could then try to print out person, but it's not going to matter because the program is going to fail as soon as we try to reassign the constant value. But we're still able to manipulate that object, which means that I can still access person.age and give that a new value. For example, I could increase it by 1, setting it equal to 28. This is invalid. I'm trying to reassign person. This is valid because I'm just changing one of the object's properties. So if we save the script in this state, we're going to see that everything works as expected. Over here in the terminal, we're going to get our object printing where age equals 28. If I did try to bring this line into the mix, we would once again see an error related to trying to assign a new value to a constant variable. I'm going to add those comments right back in, removing the line that was breaking the program. And that is it for the differences between const and let. The only difference is that const-based variables cannot have their values reassigned. Everything related to scoping or valid variable naming, all of that is identical between the two. Now at this point, people often ask, why use const at all? We've been able to get by just fine using let. Why not continue to just use let throughout the entire course? And the answer mostly has to do with code readability. So when we create a variable, we have two ways to describe the details of that variable. If we create a variable and say it's a constant, we're telling whoever's reading the code, whether it's someone else or ourselves later, that this is a variable whose value is never going to change. That makes it really easy to reason about what some code does. If a variable is going to change, that's fine. We can just switch it from a const to a let-based variable. Once again, that provides clear semantics to whoever's looking at the program. They can say, okay, this is a let-based variable, which means, well, this is the value at the moment. The value is probably going to be changed somewhere down the line, so I should keep an eye out for that. It really just comes down to semantics. It allows us to better describe what a variable is intended to do. There's no big coding challenge for this one, but I do want you to take a quick moment to analyze one of the files we've created before. This is the grade calc program that you created in the last section. In here, we have a few different variables. What I'd like you to do is go through the program and look at each one, figuring out if it really needs to be a let or if it could be a const. So take a few seconds to go through all of the variables, figuring out which way it should be declared. When you're done, you can go ahead and click play, and I'll go through the process together. See you in a second. All right, let's go ahead and move through each variable. First one, grade calc. Does grade calc ever get reassigned? And the answer is no. The only time we ever reference it is when we call it, which is not a reassignment. That means we could switch this over to a const for clearer semantics. Next up, percent. Does percent ever get reassigned? No. It gets referenced about 5 different times, but its value is only referenced. It's never changed, which means that this could also be a const. Next up, we have letter grade. Letter grade gets actually changed 5 different times, and it also gets referenced once. That means we couldn't make this a const because all of these lines would fail. We can't reassign a constant value, so this one is actually going to stay at let. We move through the file, no other variables, and right near the end, we have just one more. We have result, which is referenced a single time, and that means we can switch it over to const instead of let. So if I were given this program, I could really quickly glance at it and realize that the only variable that ever changes is this one, providing clear semantics as to what's going on with the program. When I see my constants, I can take a quick peek at them, realize their value never changes, and then move through the rest of the script, figuring out how things work. That's it for constants, nothing too crazy there. That's it for this video, but it's also it for this section. In this section, we learned about objects, which allow us to model things in the real world. They allow us to store related information in one place. Now from here, we're going to move on to the next section, which is the last section that covers JavaScript basics. So there's one more big new topic we have to cover before we can create programs that really do anything meaningful. And this is the array. The array allows us to store list-based data, which is what makes up pretty much every app out there. A list of notes, a list of to-dos, a list of emails, a list of users. So this is going to be a very important topic to explore. I'm super excited to get to that section, so let's go ahead and jump right in. In the last video, you learned how to create variables with const, and I also told you it was the last video for this section. Clearly, that's not the case. Now, it was the case when the course first came out, but after the course launched, I got a lot of questions from students. They were seeing a third way to create variables on the web, and they noticed it wasn't covered in this course, and they were wondering why. So I've added this video after the fact to talk about this third way to create variables in JavaScript. This is a var-based variable. In this video, we're going to talk about exactly what they are, how they work, and why they're something we want to actively avoid. I didn't cover var in this course originally because it is not something we use in day-to-day development anymore, but it did play a big role in JavaScript in the past. So for the sake of completeness, I'm going to talk about exactly what it is and how it works. To kick this one off, let's go ahead and create a new file in the objects directory. Down below, I'm going to call this one var.js, and in here, we're going to mess around with this third type. If we want to make a variable with let, we start with let. If we want to make a variable with const, we start with const. The third type is to create a variable with var. Now, this is going to look pretty similar to what we've done already. After we set up the var keyword, we move on to naming the variable we're creating. Let's go ahead and call this one something easy like first name. Then we could choose to assign it a value if we wanted to. So right here, I could assign it a string value, for example, and I'll just use my first name. Now this should look pretty familiar based off of what we already covered in the course. And for the longest time, this was it. This was the only way we could create variables in JavaScript. There was no let, there was no const. Those are relatively new additions to the language. Now you might be wondering, why ever create a different way to make variables? Why did let and const ever need to get added to the language? And the reason why is that var has its own fair share of quirks and flaws, making it a less than ideal way to create variables in JavaScript. So let's go ahead and talk about the basics of var. At its core, var is pretty similar to let in the fact that we can reassign its value. For example, I can set first name equal to something completely new. I could set it equal to a string, a number, an object. In this case, I'm just going to set it equal to a different string value like Mike. This is perfectly valid, just like we've seen with let. Down below, let's go ahead and actually print first name to the console. So console.log, printing the first name variable. I'm going to say var.js and run things from the terminal. Node space var.js. When I run it, without surprise, we get Mike printing. So var got us by for a while. What I want to talk about now, though, are the differences between var and const let, and why const let should be preferred. The first thing with var that we can do that we can't do with const and let is redeclare a variable that's already been created. So right here on line 4, for example, I can make a new var called first name exactly as we have it above, and I could set it equal to a different value like Jen, for example. Now we know that if this was created with let or with const, we would get an error saying we're trying to redeclare a variable that's already been created, but with var, it's perfectly fine. So if we go ahead and rerun the script, we can see that without complaining, the program is printing Jen. And that can be a pretty big problem. When we're creating programs that are significant with lots of different variables, it can be very easy to accidentally create a variable that already exists. With let and const, JavaScript lets you know and it crashes the program so you can change the variable name to something else. With var, JavaScript silently accepts what you've done, even if it might not be what you wanted to do. So in this case, we're none the wiser that we already had a first name variable that was created that accidentally got overridden. Now, obviously, in the context of a 6-line program, it's pretty easy to spot this, but if we had all sorts of different functions across multiple files, it can get really difficult to track down why some variable has had its value changed, even though you didn't think it would. So this is the first reason we want to avoid var. The next reason we want to avoid var is that var is function scoped, not block scoped. That means things like if statements, which create code blocks, don't actually create a new scope when working with var. Let's go ahead and explore that with an example. Up above, what I'd like to do is make an if statement. I'm going to replace the first 2 lines of the program with an if statement. If, our condition, our code block. And for the condition, let's just come up with something that's always going to pass. So I'm going to check if 10 equals 10. 10 is always going to equal 10, so the code inside of here is always going to run. What we're going to do is take our variable declaration and move it inside of the if statement. I'm going to cut it out right here, paste it in right here, and then we can see what our program actually does. If I save var.js, I can run things from the terminal. When I rerun them, what do we get? We get Jen printing. So var has a function-based scope. If we don't create a new function, we don't have a new scope. Since we don't make a function anywhere in this file, everything is in the exact same scope, meaning that we do have access to first name down below, even though it was defined in the if statement. We know that with const or let, this wouldn't work. So const and let are both block scoped. This creates a new block, as do functions, so we know that we wouldn't be able to access first name. If I save the program in its current state and rerun things, this time we're going to get an error, reference error. First name is not defined. I prefer working with block-scoped variables as opposed to function-scoped variables because it gives me a lot more flexibility. I'm able to maintain fine-grained control over my scope. For example, if I'm working in an if statement and I want to perform some sort of private calculation inside of there, I can create variables using let or const that are specific to that local scope. If I have to do that with var, those variables get exposed outside of the if statement as well. Now let's go ahead and create a function to prove that we can at least get function scope with var. Right here, we can make a function const set name equals, I'll set up a brand new function. It does not need to take any arguments, and all we're going to do inside of here is create a variable using var. Var, first name, with a capital N of course, equals whatever value we want to happen to provide. I'll just stick with some sort of name. So right here, we can see that if we were to call set name, this line would indeed run, but we're still not going to be able to access that down below because var-based variables are function scoped. So the only thing that creates a new scope is indeed a function. If we save the file and rerun things from the terminal, we can see we are getting that reference error like we would with let or const. First name is not defined. So that covers two of the big differences. With var, we can declare the same variable twice. We just learned that var is function scoped as opposed to block scoped. The last big difference has to do with accessing a variable before it's declared. To mess around with this, let's go ahead and delete everything we have so far and look at some pretty strange behavior. Let's start with an easy one. We're just going to make a variable using let called age. I'm not going to assign it a value, and down below, we're going to log it. Console.log, printing age. Straightforward. We know that if we don't assign a value to a variable we declare, it gets assigned undefined behind the scenes. So in the end of the day, I would expect to see undefined printing, and that is exactly what we'll end up getting. I can run the file node var.js, and I see undefined printing. The exact same thing is true with a var-based variable. If I save the program swapping out let for var, we're going to see the exact same functionality. Nothing surprising there. What's interesting and why I want to explore this third difference between the two is what happens if we try to access a variable before it's been declared. To do this, we're going to swap these two lines. I'm going to take console.log and shift it up above. So now we are logging age, then after we log age, we're declaring it. If we were to run the program, we might expect some sort of error to print saying that age has not been declared, but if we actually rerun it with var in place, what do we get? We still get undefined. What's crazy though, if we swap out var for let, we are going to get the error we probably would expect. So right here, same program, just swapping out var for let. If I rerun things, we can see that age is not defined prints. So what exactly is happening here? When we create a variable with var, its declaration gets hoisted to the top of the scope. So in reality, the program we're running still looks like this. Now things get a bit more interesting if we actually assign it a value. So let's keep our log as the first line, and on the second line, I'm going to assign the var-based variable age a value like 10. We're going to save the program, rerun things, and what do we get? We don't get 10. We still just get undefined. So once again, it is the declaration of the variable that gets hoisted. So in reality, when we run a script like this, it really looks like this. We create the variable, then we print it, then down below, we assign it a new value. So this is pretty strange behavior that we're seeing with var, and it can be really confusing when we're working with variables in our scripts. To drive this point home, I just want to show you one last strange example of reordering these lines once again. I'm going to take the first line and move it to the last line. Then I'll take the old last line and I'll make that the first line. So now we're assigning age to 10. We're then printing age, and then down below, we're declaring the variable. If we save the program and rerun things, what do we get? We actually get 10 printing. So in this case, once again, the declaration right here gets hoisted to the top of the program. So the actual program we're running looks a bit more like this. So to summarize, if we try to access a var variable before it's declared, we get undefined. If we try to access a let or const variable before it's declared, we get a reference error, and that is probably the behavior we would expect. That's going to allow us to go back, find out why we're using variables before we're declaring them, and then fix our code to actually work. This is the only video in the entire course where we're going to talk about var. It's not something that I use anymore in JavaScript development, though once again, it was very important in the past. We now have better tools for the job though. So in this course, we're going to be sticking with let and const. I'm going to go ahead and delete this file from the objects directory. That is it for this video. I will see you in the next video, which is the section intro for arrays.